right, we are here on day one of Magic Box. I'm super excited today because I get to teach you guys a project that I've never taught any students before. If you don't know me, my name's Coach Ed, and I love doing things for the very first time. That's just, to me, the most exciting thing because I don't want to do the same thing over and over again in my life. And so that's actually part of what it means to be a Barnabas engineer. It means we try new things. All right, so here we go. Magic box. This is a magic box. It's not really magic, but I like to call it a magic box. So the way it works is that, schools have me go and put out tables and put out my robots, and kids come up and ask me, Mr. Ed, tell me about your robots. So with this one, I would say this is the magic box, and here's what you need to do. You need to open the box without touching it. And so kids are like, what are you talking about? How do I open a box without touching it? Well, we'll talk a little bit about sensors and that this box can actually sense where you are. And so how it works is you see these two eyes here. This is an ultrasonic sensor. It works just like the way that bats see through echolocation. Dolphins and whales do the same thing. So we'll learn more about that in the coming weeks. But that's basically how this thing works. As you get close to these two eyes, it's able to sense it, and then it's able to then open the box, and the box will open like that. All right, so I have a battery here. Let's go ahead and try this thing out. So let me grab my battery. All right, guys, I got my battery here. Let's plug in our magic box to see this thing in action. All right, so I got this going on here, and I'm gonna plug it in. Here's my power jack on my Arduino here. Okay, now that it's in, you can hear it. You can probably hear that motor in the background. It might be that clicking sound. Oh! So covered the eyes, it's open, uncover, closed. Cover the eyes, open, closed. All right, so that's how it works. Now, today, I actually want to go through the prototype process with you. Let me unplug this so that it doesn't keep making that sound, that motor sound. All right. Yeah, it seems like the battery was causing the motor to cause this clicking sound because it's energizing the motor. Anyway, so I have that unplugged, but we can still watch this. Okay, so now that we can look at this thing, let's go through the prototype process. So it's very important for us as engineers to learn how to prototype, and that means that we're able to take a concept and then really quickly come up with the process of how am I going to do this, step 1, 2, 3, 4, 5, or however many steps it is, and then actually to go through and succeed in that. So it's important that we can do it quickly. It's also important that we do the steps in the right order. And so there's actually a skill to being able to do that. So let's walk through that together. So I'm going to say we got to make this thing. I just showed you what this looks like. So where do we start? Well, for me, I always look at the body. So first day of class, I say robots all have bodies. If a robot doesn't have a body, that thing is probably not a robot. So I always look at, let's look at the body. So what's the body in this robot? Is it this stuff or is it this thing in here? Well, this stuff is the electronics. So I call this the brain. Okay. But looking at this is actually going to be the body. So what's the body made out of? Well, it's all the mechanical stuff. It's the stuff that the thing is made out of. So think of our bodies. It's going to be our bones, our arms, our head, that kind of thing. So what are the bones and the arm and the head of this robot? Well, he doesn't have bones, but he does have cardboard, okay? Inside here, there's like a rock. I guess there's a key in there just for fun. There's also some metal right here. I think it's to keep the something to do with this chopstick, and it has a chopstick I guess that helps it open, and then it has a motor. So all these things are a part of the body. So that's something to keep in mind. All right. So I call this the brain of the robot. All right. This is what controls everything. So I would say, well, I also need something to control everything. And so I look here, and then I see, let's take a closer look. This is an Arduino board. Okay. So do we have, maybe I could get an Arduino board of some sort. That's going to be the brain. That's going to be the part that controls when the robot opens, when the box opens. Okay, cool. What else do I see? I also see that, you know, when I turn this thing on, it opened. So there's something that moved. There was a driver of the motion, which in this case would be a motor. Okay, so if you look inside, there's a motor in there. All right. Now, so you probably need a motor of some sort to drive the motion. So now you start thinking, if I'm your engineering boss, I'm like, okay, you need a motor. What kind of motor? There's all sorts of types of motors. There's two main types of motors that we use in our projects. One's a DC motor and one's a servo motor. What's the main differences between them? DC motors, when you turn them on, they just keep spinning, going and going and going. When you turn on a servo motor, which is the other type of motor, and it's a little bit harder to control. It's not going to just start spinning right away. You actually have to use a computer board to control a servo. But using the servo, you can make it spin to specific positions. So if you look at this, if you remember, it went like this. Okay, I'm going to turn it like this way so you can kind of look at it. Did it move the motion all the way around, like a full circle? Watch it. There's a little chopstick right here. No. It moved maybe around half a circle. So if it's not spinning all the time, then you probably, or all the way around, you probably don't need a DC motor. I would say, hey, I think I probably need a servo motor. Okay, cool. So we know we need a box. We know we need a brain, Arduino brain. We also know we need a motor. And we know we need to probably have a servo motor because it's not going to be spinning forever. It's going to just go back and forth. What else? Well, the last big thing that I would want you to pick up on as my young engineer is that there was a trigger point. So this robot, it didn't just open whenever I plugged in power. It only opened whenever it sensed something, which was this thing, right? So I would say I need a sensor. I need some type of sensor that is able to tell when somebody or some object is close to it. So there are many other sensors there. I gave you a hint. It's an ultrasonic sensor. You could also, if you think about it, you could use a button, right? A button is also something that could work where you push the button and it opens, which would be kind of cool too, but then, it's not really magic, right? It's kind of like you still touch it and then it opens. If you had a heat sensor, that would be interesting. You could also hook up a heat sensor because your body has temperature. Maybe if you got up to it, it could sense it and then open. So there's other ways to do this, and actually I want you guys to keep that in mind. There's not only one solution to this thing. So anyway, so we're going to have some kind of sensor. In our case, it's an ultrasonic. All right. Now you may have also noticed this part right here. This is a numeric display that can show numbers. This was actually telling you the exact distance that the ultrasonic sensor was sensing. So, for example, like if your finger was 10 centimeters away, this thing would say 10. If it was 50 centimeters away, this thing would say 50. For this project, because we only have three short days, we probably won't get to this part. but that's kind of just like an FYI. But that's more of like an extra thing. Like our project will still work without the numeric display. But if you have one of these at home, or if you want to try to add it later, you can always do that. Just call me up or shoot me an email or whatever, and I will show you where to get this part from us, and I can even show you how to do it. All right, so now that we have some concept, let's go ahead and write that down. All right, so here we go. Whiteboard. Okay, and I challenge you. You should probably give this a shot. Like, sketch it out on some paper. This is how real engineers do this thing. So we're gonna call. What do we call this thing? Magic box. Magic box. Okay, great. We said there's gonna be some kind of box. Okay, I'm gonna try to draw 3D here. Check that out. I think that's not too bad. All right, and box. All right. Maybe I want to even draw like it has like a lid, right? Okay, because that's the part that opens and closes. That's going to be the body, remember? And then I'm going to need a arduino. Okay, that's going to be the brain. Now the Arduino is going to connect to the box, and if you remember, we needed the thing to move this, so we had some kind of motor here. Right, so it was like somewhere around here. So this is motor. And it was a servo motor so that it could move half a circle about. If you guys don't know, half a circle is 0 to 180 degrees. All right. Okay. And then, let's see. So this would connect to there. All right. And then we also have the sensor. Okay. So our eyes. This is going to be ultrasonic sensor. And then this would also connect to the brain. All right, so we got our box, motor, ultrasonic sensor, and then our brain. And then I'm going to also add on here, since I want to be complete, I want someone to, when they look at this, be able to see like, oh, I can see how this thing works. So the next thing is they're going to probably ask like, well, how's the box going to open? Well, I'm going to put something on this. This would be like a stick, okay? And the stick is going to swing up, and then hit the box lid to come open. And that's how it's going to work. Okay, so I think it looks pretty good. I think this makes sense. It's a good concept for my prototype. And we came up with this together. One last thing I would say, just to be complete here, our thing can't run without power, so we're going to also connect a battery. Awesome. So we got a battery connected to the Arduino, and then that Arduino is going to control everything. All right, so while we have this, I'm going to go through together right now what the plan should be for this robot. All right, so let's say step 1. And I'm going to change colors here. Okay, so let's go ahead and figure out, all right, so what what's the process here? What do we do first in order to make this thing come to life? So I would say number one, maybe that's not really showing up. That's not a good color. Okay, so the next step here is to think about what's the first thing to do. You know, I want to come up with a plan so that we can finish this thing in 3 days. Well, let's see. Could we work on the hardware first? I guess we could. We could say, like, we're going to work on the brain, and then inside here, actually I forgot, we got to put code in there. Okay, we're going to put code in there, and then we're going to build the box, and then we're going to add this. Well, what's wrong with that? Here's the thing here's the downside. You could try that, but here's the thing. You could put code in here, but if you put code in there, but you don't even have a box yet, and you don't even have a motor yet, how do you even know what your code does? You know what I mean? So that wouldn't be good. I call that you're coding blind, because you're putting code in here, but you don't even know what the code does because you didn't connect anything to it. So when you're doing robots, when you're building robots, it's usually not the best thing to start with the code. Okay, maybe sometimes you do. And maybe if you're working in a team where you're just the code team, you work on this because someone else is building that. But since we're doing everything ourselves, I would say the best step is to work on this guy first. All right, so I would say number one, build box. All right, so that's the box there. And then I would say number two, or I'll say within building the box, I want to attach servo. Okay, so that's this, putting this onto the box somewhere. And then I would say attach stick. Okay. And then number two, once I built the box and I attached the servo and the stick, then it's able to open, right? Now I'm going to attach this to the Arduino. So number two is attach motor, or I'll say servo, to Arduino. Okay, so now I attached it to the Arduino. Now you see how this is a better process because I've built the box already, I've attached the servo, and I attached the stick. Now I connect it to the Arduino, and then now I can code Arduino to open box, right? So this thing's already set up now. Now I can use the Arduino to open the box through code. And so because I have the box already set up, when I code, I know exactly what it does. If it doesn't open the box, I can change the code. If it opens the box and opens it way too far, or just maybe it opened like just a little bit, like that, but not enough, I can adjust that thing in the code. Okay. All right. So now at this point, by step three, hopefully I would have a box that is able to be opened with the Arduino. There's no sensor yet, right? But it's at least I can code it. Maybe when I just plug it in, it opens the box. Not bad, not bad. If I can get to that point, I'm doing great. All right. So 1, 2, 3. Now 4, I would say attach ultrasonic sensor. Okay. Then I want to attach the ultrasonic sensor, and I'm going to actually attach ultrasonic sensor to Arduino. Okay, so ultrasonic sensor then goes to Arduino, and then after I've attached it, I'm going to code this sensor so that it only opens when someone's close. So I'll just say code sensor and servo to open when someone, oh, I think I lost you guys, when someone is close. All right, so here's our plan. Hopefully you can read it. Hopefully you wrote it down too. This is important, guys. I want you to actually go through the prototyping process with me. The more you're able to do this, the more you're going to be able to actually build some really cool stuff. Because if you start at the wrong spot, it's going to be a harder process for you, right? So it's important for us to first learn, we got to build the box first. Then we're going to attach the servo to the Arduino, okay? Because the box already has the servo and the stick on there. And then we're going to code the Arduino to open the box. And then we'll do the ultrasonic sensor. And then we're going to code the sensor to open and close when someone is close. All right, we have our plan. Today, let's do a few of these steps. So we just finished our planning process. Now we're going to start with the first couple steps. Okay, so thinking back to our list, the first thing we want to do is build the box. And then after we build it, put a motor on there and with the chopstick. So let's first do that. First thing, build a box. I think I gave you guys a box that looks like this. Go ahead and just put it together if it's not together yet. If it's already put together, there you go. You got your box. Boom. I went ahead and I cut this part right here because I thought that it might kind of open and close easier, but you don't need to do that. Also, if you want a bigger box or a smaller box at home, go for it. It doesn't have to be this box. Actually, I'm curious. I'd love to see what kind of box you guys use if you want to use something else. All right, so I got a box. That's probably easiest part. Get a box. Okay, now we have to put the motor in the box. Now, if you remember, what happened was it had a stick or something, right? The stick would be inside. Let me turn it maybe like this. The stick would be inside, and then it would push it out like that. So how are we going to do that? Okay, we have to somehow position this chopstick in there like that. So then what if we put the motor in there like that? Okay, so before we do that, let's first look at our motor. All right, the motor needs to have a coupling. Okay, so we're gonna put that on here. There, it's snapped on there. Now this thing is just gonna fall off all the time. So you gotta get one of these screws. This one's like a mid-size. There's a smaller one too. Either one is fine. And then let's screw this guy in. Okay. Screwdriver. If you have another bigger one at home, that works. Okay. Let's screw it in there. Okay, now turns. Okay, I always say be careful when you do this, guys. I'm testing the range of motion, which is good, but if you twisted it and kept twisting, it's going to break the gears in there. So once it stops, just let it be. Just let it be. Okay. Back and forth, only half a circle. Okay. Now, before we attach this to here, I think it might be good to first put on the chopstick. I mean, it doesn't really matter, I think. You could also put this in first and then put the chopstick, but either way. Today I feel like let's do the chopstick first. Okay, so let me think. Let's first get this chopstick. Okay, the right length. Okay, I think this is too long. So let's kind of see. If I have my motor somewhere in there, then my chopstick will be like that. I'm thinking like maybe cut it there. Maybe like cut it right there where my fingers are. So I'm gonna have to get scissors of some sort. Your chopstick might be the right length. I need a cut now. You know, I'm gonna cut, and then what I like to do, if you just have regular, don't like ruin any scissors, right? You just kind of just put a little nibble on it, okay? Once it's kind of, see, it's kind of nibbled now, right? You see that? It's like dented. Now you can just go like that. All right, cool. See, I got two now. Maybe one of these, I can make 2 boxes. All right, but anyways. All right, take one of these. Now check it out. Okay, this looks about, this looks about right. Okay, now I gotta get this thing onto here. Okay, so what that does is that it opens and closes. Okay, so now I gotta get this thing onto here, and what that does is that it allows this white propeller to transfer the motion all the way to here. All right, we're expanding the white motor coupling range of motion. All right. Okay, so all I need is some of this. And then I'm gonna do it 2 areas. All right, here. Wrap it. Now it's important we do not put tape on the blue motor part because that would restrict this from moving. All right, so remember that. Don't put tape like that. You don't want to put tape on the blue part. Okay, it's gonna make the whole thing get stuck. That's not what we want. All right, so we go like that. Okay. Okay, that's pretty good. If I feel it's kind of loose, that might break later, so you guys should probably do this too. Let's just put some extra tape on this guy. Fortify him, make him strong, okay? All right. Okay, not bad, not bad. Okay, now this, let's put it maybe like, I'm thinking like this would be good. Okay, and then when I test it, let's see, oh, this is interesting, look. Okay, so if I put it like this, right? I want this stick to go up this way, but it won't. It goes down that way, so this is not gonna work. I need it to go up this way. Do I need to change the position? Maybe I need to flip this stick around, right? Like maybe reverse it. So undo the tape and reverse it. Or what if I put it on this side? Would that work? Let's see. If I put it on this side, oh, this side it works. See, we can always figure things out, and there's many ways to fix it. I could have kept it over on this side, but then I would have had to change the position of this. I would have had to take the tape off and redo it. So I think this is good. It's it's gonna go like that, and boom, hit it up. It's gonna be closed, and then it's gonna, boom, hit it up. All right, so let's put some tape. So how are we gonna put some tape there maybe? This, sticky foam. All right, let's take one, put it here on the bottom. All right. And then it's gonna go, I think around here would be good. Oh yeah. Check it out. Okay, so I got potential now. Let's check my list, all right? Okay. Step 1, build the box. Attach servo. Attach stick. Check. Okay. Number 1 is done. Number 2, attach servo to the Arduino. All right. Well, let's see what we got here. We got this guy, the Arduino, and if you see here, there's these pins right here, okay? These 3-pin headers. It says servo 3, servo 9, servo 10, and servo 11. All right, let's go ahead and stick it into servo 9. And this is how you want to do it. Stick it into servo 9, like that, okay? And you notice the brown of the servo is facing down. Let me hold it closer, okay? The brown cable is facing down toward the feet, and the orange is facing up here, and it's on servo 9. Make sure it matches up with those 3 pins. Okay, let's show you the side. Okay, so now we connected to the Arduino. Let's see here. I'm backwards. Okay, and I lost my pen, but that's all right. We've built the box. We attached the servo to the Arduino. Check. So we've done step 1 and 2 today. I think 3, 4, and 5, we could probably do that in 2 days. Should be no problem. So I'm going to save that for the next 2 sessions. All right. So hopefully you guys had a good time today. We learned about prototyping. We also were able to build a box, add a motor, and attach it to the Arduino. Next week, we're going to program this thing to move. All right, guys. So that's it for today. Hopefully you guys learned something. Take care, and I'll see you around. Bye.